minutes away from the nearest hour am I? 0, okay, because you are at the nearest hour. How about at 12:15? 15? At 12:30? How about at 12:45? You're only 15 minutes away. Then do you see the pattern? And I think I had a teeny tiny typo in here. This is supposed to be 2:45 in between. So it's going to have a pattern of 15, 30, 15, 0. 15, 30, 15, 0. Do you guys see that pattern? So then let's make a grid here where on our y-axis we're only going to need to go 15 and 30, but we'll start here at 0 is really like 12 o'clock. Then every 4 tick marks will be another hour. Then let's plot it. At 12 o'clock it's 0, then we go up to 15, 30, 15, 0. So there's definitely a pattern happening here. This graph is an example of a periodic function. In this lesson, you will learn about the characteristics of graphs that are periodic. And periodic just means that the graph has a repeating pattern, that there is a certain length on the x-axis in which it's almost like you would be taking a stamper and you could just keep stamping, stamping, stamping the exact same pattern along the x-axis. Okay? Any questions on how we plotted that, how we came up with it? And can you see how long does it take for it to repeat? An hour, right? It only takes 1 hour and then it repeats 4 times. Okay, in example 1, this is the parent function y equals sine x. So what I need to tell you is that the length that it takes the graph to repeat is called the period length. And for sine and cosine, the parent functions have a period length of 2 pi. We have something called amplitude, and I will formally define these in a moment, but the amplitude here is 1. The domain for the sine curve is all real numbers. And the range is -1 to 1 on the y. So let's draw a grid here. And what I like to do is I like to, when I'm graphing my trig functions, I count 4 tick marks to the right and I plot the period length. So we're going to count 1, 2, 3, 4, and the period length for the sine function to repeat, its pattern is a length of 2 pi. So then what would be the second tick mark? Sorry, that's me. Isn't that pi? Okay, this halfway would be pi. So we're going to make 4 tick marks to the left and label it negative 2 pi. Then the second tick mark is negative pi. Then you're going to go up to the amplitude or down to the amplitude. And something we need to do in order to graph the sine is we need our unit circle. So the unit circle didn't go away. Let's go ahead and jot down those 4 main points on the unit circle. And you will find as we continue through this chapter, especially on solving trigonometric equations, you have to have your unit circle down. Okay, and you guys also remember that every ordered pair went cosine theta, comma sine theta. So when I'm trying to get what I like to call the 5 main points for the sine graph, I come here to 0. What is the sine of 0? It's 0. Then if I rotate up here, pi over 2, what's the sine of pi over 2? It's 1. What's the sine of pi? 0. What's the sine of 3 pi over 2? Negative 1. And what's the sine of 2 pi? 0. So here's the sine curve. These are your 5 main points. So it becomes easier if you can just remember the sine curve starts at 0. It goes up to amplitude 0, down amplitude, and back to 0. Then you can see what the pattern is. Where would my next point be if I go left? Am I going to go up to 1 or do I go down to 1? You're going to go down to 1, and then it comes back to 0, goes up to 1, and so you want to continue the pattern. So what I've actually graphed is 2 period lengths. 0 to 2 pi is 1 complete cycle, and 0 to negative 2 pi completes a second one. Okay? All right, now let's go ahead and do the cosine. The cosine has a period length of 2 pi. It has an amplitude of 1. It has a domain of all real numbers. And it has a range, negative 1 to 1. Let's look backwards a moment on example 1. Can you see now why sine has a range of negative 1 to 1? And I know I introduced it back in chapter 13 when we did our inverse sine, because I think it made more sense to know what it looked like. All right, so here we go. You make 4 tick marks to the right and call it the period length. The minimum I'd like you to do is label the second and fourth tick marks. You don't have to label all 4. Okay, then we can come back over here to the unit circle. What is the cosine of 0? 1. So I'm going to start up at 1, and then I just go around the circle. What's the cosine of pi over 2? 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. Okay? I don't know if you guys are still asleep because it's early in the morning or what here. Then you just follow your pattern going to the left, and there it is. Now it does oscillate forever and ever going to the right to positive infinity, and it goes forever and ever oscillating to the left. Okay, so these are your 2 parent functions for sine and cosine. The domain will be all real numbers. The range is y is oscillating from negative 1 to 1. Now the amplitude here is 1, but a formal way to find amplitude is you take 1/2 the maximum value minus the minimum value, because this will help us later as we go on. The x-intercepts for cosine. Well, let's look at where does the graph of cosine x cross the x-axis. Well, going to the right, isn't it pi over 2 and 3 pi over 2? But on the other side, isn't it just negative pi over 2 and negative 3 pi over 2? So we could just put plus or minus in front. Are these the only ones? No, because it keeps going and going and going. What do you think the next one is, if you had to guess? What would be the next x-intercept? 5 pi over 2. That'd be a good guess. So you're just going to keep going the odd pi over 2's, okay? Now let's look at the sine curve. Let's look at the sine curve. Let's look at those x-intercepts. I have 0, pi, 2 pi. And, of course, you can't do plus or minus 0. That doesn't make any sense. But we would have plus or minus pi, plus or minus 2 pi. What would be the next one? Would it be 4 pi? 3 pi, right? Nashawn, why is it 3 pi?
Because you're going by 1 pi each time.
Yes, do you see that? It's crossing every distance of a pi unit. So it's actually 3 pi and then 4 pi. You see it? We did have a pi right here. Okay. All right, the amplitude and period of the graphs of y equals a sine bx and y equals a cosine bx are the following. The amplitude is a distance, and distance is non-negative. So my amplitude, oops, I just put the wrong letter in there, sorry. That's the absolute value of a. Sorry about that. And the period length is always 2 pi divided by b. Okay? All right, graphing key points. There are 5 key points when graphing y equals a sine bx and y equals a cosine bx. These are where the maximum and minimum values occur and your x-intercepts. So those are the 5 key points that I graphed with you on the parent function, okay? So I'm going to give you some steps to write down that will help you with your graphing, okay? So step 1. Determine your amplitude and period length. Step 2. Make 4 tick marks to the right and label the 4th tick mark the period length. I'm not done with my steps, but let you catch up with me. Step 1, determine the amplitude and period. Step 2, you make 4 tick marks to the right and label the 4th tick mark the period length. Step 3, make 5 key points using your amplitude and knowing where cosine starts and where sine starts. Step 4, continue the pattern to the left. Okay, so you do it to the right, a whole period length, and then you do it to the left. All right, so as you do each of your graphs, I want you to make sure you're going through these steps, because if you keep going through the steps, you'll get them in your head. So here we go. If you want to find the amplitude, remember we're looking at y equals a sine bx, okay? That's what it says up in the definition above, right up here. The amplitude is the absolute value of a. So it's the absolute value of 4, which is 4. Amplitude is half the distance from the maximum to the minimum value. So distance is non-negative. The period length is 2 pi divided by b. Well, b is the number in front of x. It's y equals a sine bx. So if there's no number in front of x, it's understood to be a 1. So I'm going to make a grid here, and I'm going to count 4 tick marks to the right and call it the period length. I'm going to go ahead and be proactive and go ahead and do it to the left. Now, step 3 says you're going to make 5 key points using amplitude. My amplitude is 4, so I want to go up 4 units and down 4 units on the y-axis. Now, until you get it memorized, you're going to want to draw your unit circle, okay? Until you have it memorized in your head, you need to draw your circle. Where does the sine function start at 0? Does it start at 0 or at 1? At 0, right? So if you don't know that, you draw your circle, and it's the ordered pair 1, 0, so sine of 0 is 0. Now, instead of it going up to 1, it actually goes up to the amplitude. And then remember, we had our x-intercepts at the pi's, and then it goes down to the amplitude and back to 2 pi is 0. And then you're going to continue the pattern to the left. Okay, so step 3, when it says make 5 key points using amplitude, you need to know where the graph starts. Sine starts at 0, cosine starts up at 1, or at the amplitude. Okay? All right, I'm going to need to erase my steps so that I can get my graph in here. But you guys have the steps there. All right, step 1, we're going to determine the period and amplitude. So the amplitude is the absolute value of A. What is A here? 1. So I'm taking the absolute value of 1, which is 1. The period length is 2 pi divided by B. What is B here? 4. So this reduces. We reduce all fractions. So the period length is pi over 2. So I'm going to make 4 tick marks to the right, and I label the 4th tick mark the period length. Now what would the second tick mark be? What's halfway? What's half of pi over 2? Pi over 4. Then let's be proactive and make 4 tick marks to the left. And if you're not sure how I got that pi over 4, take 1/2 times the pi over 2. That's where you get your pi over 4. Okay? My amplitude is 1. then cosine will start at your amplitude. So this starts at 1 because the amplitude's 1. Then it goes 0, -1, 0. And then continue your pattern going to the left. Now what I want to point out to you is even though the graph looks identical right now to the parent function, it actually is not, because this is going on the x-axis from 0 to pi over 2. So how many, if that's one period length from 0 to pi over 2, I want you to think here a moment. If the parent function goes from 0 to 2 pi, how many of these cycles are inside 0 to 2 pi? It's not 2. Anna, how many? There's 4, because from 0 to pi over 2 is 1. There'd be another one from pi over 2 to pi. There'd be a third one from pi to 3 pi over 2. And a fourth one from 3 pi over 2 to 2 pi, okay? So it's really like there's a whole bunch of them in there. But the way that I'm teaching you how to graph these, it's making it as simple as possible, okay? All right, let's try letter C. What is my amplitude here? It's 1/2. Don't forget, as we start doing some negatives, okay, once we start getting into the negatives, that'll make the absolute value make more sense. The period length is 2 pi divided by b. Remember, b is anything that's in front of the x. It's whatever the coefficient is. So what is b here? 2 pi. Well, wait a minute. 2 pi over 2 pi, what does that equal? 1. All right, so my period length is 1. So I make my grid, I go 4 tick marks, and I call it 1. So then clearly the second tick mark would be 1/2. I make 4 tick marks to the left. And then here we're going to have to go 1/2 for amplitude. Now cosine starts at my amplitude. So it's not going to start at 1, it's going to start at 1/2. And then it goes down, and do you see it really is the same pattern over and over and over again. Okay? All right, any questions on that one? So it's really not that bad. So let's look at the amplitude in letter D. It's the absolute value of 1, which is 1. Now the period length is 2 pi divided by 1/5. Well, that's 2 pi times the reciprocal, which 5 over 1 is just 5. Okay, if I multiply by the reciprocal of 1/5, that's 5. So my period length is 10 pi. So what would be the second tick mark? What's halfway then? 5 pi. My amplitude is 1. All right, then when you're ready, go ahead and plot those. All right, so now where does the sine function start? At 0, and then it goes up to the amplitude. And so notice the domain will always be all real numbers, but did you notice that your range will actually change? If I go back to letter A, My domain is all real numbers, but what's my range? Isn't it -4 to 4? Okay? The domain for sine and cosine will always be all real numbers. However, the range is going to vary. All right, note, the periodic nature of trigonometric functions is useful for modeling oscillating motions or repeating patterns that occur in real life. Some examples are sound waves, the motion of a pendulum, and seasons of the year. It is always neat. January 1st or 2nd, the Columbus Dispatch always has, on the back of the metro section, they will have a graph of the temperatures of all 365 days of the year, and it's actually a sine curve. So if you can remember that next year, look at the back of that section and you can see it. In such applications, the reciprocal of the period is called the frequency, which gives the number of cycles per unit of time. So frequency is an important concept, and it's just the reciprocal of the period. So in example 4, a sound consisting of a single frequency is called a pure tone. An audiometer produces pure tones to test a person's auditory functions. Suppose an audiometer produces a pure tone with a frequency of 200 hertz. The maximum pressure P produced from the pure tone is 2 millipascals. Write a sine model that gives the pressure P as a function of the time t. So we want to have a function, instead of it being y and x, we're going to do it in terms of t and p of t. So I have a function that's the pressure of P in terms of time. Now the period, remember, is 2 pi divided by b. But period is the reciprocal of the frequency. So my frequency was 200, so the period is 1 over 200. Okay, do you see what I did? The frequency is defined to be the reciprocal of the period. So if frequency is 200, the period is the reciprocal of that, 1 over 200. Now we can just cross multiply, and I know B then is 400 pi, so I'm going to plug that in for B. A, if you know the maximum isn't the amplitude, that's how high up it's going to go, but then it's also going to be how low it's going to go. So A is actually 2. So here's my function. P of t equals 2 sine 400 pi t. And that's all 400 pi t is inside that sine function.